Today we're going to be looking at oxidation reduction reactions, and these are also called redox reactions. And we've already been using these reactions and seen them in lab without actually calling them redox reactions. Some applications of redox reactions where you would see them in real life. A lot of biochemical reactions have them, so you can see an example here with photosynthesis or cellular energy, so cellular respiration, how your body is going to break down food and use it. That all has to do with redox reactions. In the industrial processes, how ammonia gets broken down into nitric acid and is used as a fertilizer, your car battery and how that all functions and works is going to be industrial uses. So by the end of the video, these are some of our learning goals that we have. You should be able to explain redox reactions, identify parts of redox reactions, and then determine both what is being reduced and what is being oxidized. We're going to start by looking at these 4 different questions, and finding the answers to them will help us to meet our learning goals then. For the very first question, what are oxidation reduction reactions or redox reactions? Basically, they are going to be a high energy reaction where high energy electrons are going from one atom to another atom, and it produces a lot of energy. That's what redox reactions are. You'll see them in the formation of compounds from an element. All combustion reactions are redox reactions. You'll see them in reactions that generate electricity, in reactions that produce cellular energy. So you see a lot of different examples of those. The second question, what happens to an atom if it is oxidized? This picture is very simple for us, but here you have an atom with its nucleus and an electron that's going around the nucleus. If it leaves that atom and goes to another atom, then it is being oxidized. So what happens to an atom if it is oxidized? It loses electrons. That is what happens. And the next question is just the opposite. What happens to an atom if it is reduced? What happens? It gains an electron. And so it's going to gain an electron from a different atom. This little analogy here and play on words really can help us to remember what happens for both oxidation and reduction. We have an oil rig, and if you think of oil rig, the letters stand for oxidation is losing, so that would be losing electrons, compared to the rig part is reduction is gaining. So think of if an electron is being lost or if it's being gained, and then apply it to oil rig to remember which is happening. So here's that terminology for you again as just a reminder. And you can see in an equation here, if we got element A and element B as our reactants, if element A loses an electron to element B, then when we look at the product side, we can say that A was oxidized. It lost electrons. And we can say that B was reduced because it gained electrons from the reactant side. 2 other terminology words that you'll hear is the oxidizing and the reducing agent. And the difference between the agent is that it's the element that causes the oxidizing or the element that causes the reducing. In this diagram down here, element A is being oxidized, but because it's being oxidized, because it is losing an electron, it is actually then the reducing agent because it is causing something else to gain an electron. So they work opposite each other, the agent part. So I won't worry too much about oxidizing or reducing agents, but just know that the agents are the cause of it. All right, last question. What is an oxidation number? Oxidation number is simply the charge that an atom would have if it's an ion. What is it going to do with its electrons in its valence shell? And we've talked a lot about that throughout the year. According to where it is on the periodic table, you know how to predict that. And so now instead of just saying it is an element's charge, we can actually say it is an element's oxidation number. Okay, so let's start applying this idea of putting the oxidation numbers together with figuring out what's going on in a redox reaction. Here are some general hints for figuring out oxidation numbers or figuring out a charge. If an element is ever going to be on its own, its oxidation number is going to be 0. So here we got calcium. Its oxidation number just on its own is 0. Same with sodium. And oxygen, even though there's 2 of them, it's a diatomic, it's still 0 because it stands alone. Second one, for ions, the oxidation number is the charge. So if there is a compound that has a charge listed, such as these polyatomics, then the oxidation number is that charge. And we can figure out some of the individual oxidation numbers within here. So oxygen is going to have a -2, and there's 4 of them, so that's a total of a -8. And so then I know that phosphorus is going to be +5 because it has to equal a total of -3. Over here, oxygen is going to have a -2, hydrogen is going to have a +1. Typically, we've been wanting those to balance to 0, but because this is an ion, a polyatomic ion that has a charge, we want our oxidation numbers to equal that charge. The third hint for figuring out oxidation numbers in an equation is in a neutral compound, such as these 2 examples we have listed, the sum of the oxidation number values are equal to 0. And this is what we've been practicing all along as we've been working on ions and ionic compounds. So here, sodium would have a +1 and chlorine would have a -1, and those balance out to 0. Here, hydrogen would have a +1, but because of its subscript, we remember that's kind of a ×2, right? And then the oxygen would have a -2. So overall, they balance to 0. And the last 2 to point out is just hydrogen and oxygen. Depending on what hydrogen is combined with, either nonmetals or metals, it can take on a +1 or a -1 charge. And oxygen, most of the time, is going to be a -2. The only time oxygen is not a -2 is if it's with a peroxide. But we're going to be using it in the -2 form most of the time. So why don't you go ahead and pause the video and practice these 6 different practice problems, figuring out the oxidation numbers. When you think you have them, start the video up again to check your answers. Check to see if your answers were correct. You'll notice that we're splitting up the polyatomics now, and we're looking at each individual element separately. Okay, so now let's apply our redox reactions to the entire reaction, the whole equation. What I have here is we're making water. We're combining hydrogen gas with oxygen gas to produce that water. And we need to figure out what is being oxidized and what is being reduced. In order to do that, I got to figure out the oxidation numbers. For hydrogen, it stands alone, so it's going to be 0. Oxygen, right now, it's standing alone, so it is also 0. Over here, hydrogen and water, or hydrogen and oxygen are together, so the hydrogen will be a +1 and the oxygen will be a -2. And that still is going to equal 0 because I am remembering that the subscript here would multiply that by 2. So when I look at this, I can see that the hydrogen changed from a 0 oxidation number to a +1 oxidation number. And I can also see that the oxygen changed from a 0 oxidation number to a -2 oxidation number. Therefore, that tells me hydrogen lost an electron because it went up in charge. And if it lost an electron, I'm thinking of oil rig. So if it lost it, that means that it was oxidized. So I'm going to label my hydrogen as being oxidized in this particular equation. And oxygen went from 0 to -2. So that tells me that it gained 2 electrons. So if it gained electrons, that's the rig part of oil rig. So that's going to be reduced. And I can just label those like this. Why don't you go ahead and try this particular equation as a practice? So pause the video, think of your oxidation numbers, and then try to determine what is being oxidized and what is being reduced. After you figured out the oxidation numbers, hopefully you got the same answer as what I have here. The next thing we're going to do with this is we're going to build this off into half reactions, or the half equations. So like I had just shown before, we have the hydrogen is being oxidized and the oxygen is being reduced. So I have that labeled. I'm going to just shorthand it here. Oxidized and the oxygen was being reduced. So I can write these as half reactions to actually show what is happening with the individual electrons. In order to do that, I'm going to take my hydrogen to start with for my oxidation. And I'm going to start here with I have 2H2. And the hydrogen is losing an electron. Remember, oil rig. So it starts just with hydrogen, but then my products from that is going to be the H2O, which it turns into, plus 2 electrons. And the reason why I know I lost 2 electrons, even though the charge went from 0 to +1, is because I have a 2 coefficient. So because of that, I know that there's 2 electrons that got lost. My half reaction for the reduction is going to be my O2, and the O2 actually gained 2 electrons, so I'm going to write it on the reactant side, and after it gained 2 electrons, then it was able to turn into the water. Why don't you go ahead and go back to this equation that you did just before to figure out what was oxidized and what was reduced, and go ahead and make that into half equations and half reactions. See if you can write them out showing how the electrons are gained or lost. As you check back on your answer here, see if you had the same half reactions as what I had listed. Okay, we got one last one for you to practice, and here we're going to try to put everything all together. So I put a step-by-step for you. You want to first go through and find your oxidation numbers. Then you want to figure out what is being oxidized and what is being reduced. And then lastly, see if you can split that into half reactions. If you want to try this on your own, go ahead and pause the video and then check back with us. If you want to have a step-by-step through this, then go ahead and just keep playing it, and I will do that for you. So to start with, as we find the oxidation numbers, magnesium stands alone, so it is 0. Hydrogen is +1 and chlorine is -1. On this side, magnesium is going to be +2 because chlorine is -1, but there's 2 of them. And then lastly, hydrogen is standing alone, so hydrogen is going to be 0. So when I look at the reactant and the product side of the equation, I can see that my magnesium changed in oxidation number, and I can also see that my hydrogen changed in oxidation number. And the chlorine had no change at all. So the magnesium went from 0 to +2, which means that it lost electrons. Therefore, this was oxidized. And the hydrogen went from a +1 to a 0 charge. So that means that it gained electrons, it gained negative charge, and so it was reduced. The last part that I need to look at here is writing my half reactions. So for my oxidation, I have magnesium, and magnesium went into magnesium chloride, and I lost those 2 electrons. For reduction, I had the 2HCl, and the H's in those gained 2 electrons, and they did that because of the coefficient. That's where I got the 2 from instead of the 1. And then I was left with my 2H2. For those of you who are checking your answers, hopefully you found the same thing that we have here, and hopefully this video was helpful. Have a good day.